in this example, guys, we can't divide our denominator into our numerator like we did in the last one, right? But one thing that we do understand here is that my degree in my denominator is larger than the degree in the numerator. And you might say, but Mr. McLogan, there is no variable. There's no degree in the numerator. And I say, well, yes, physically shown, there's not one there. But do you guys remember in binomial expansion, what did we do when we just had the constant? Do you remember what variable we had there? It was at the ends. Yeah, it was 0. Can't we put an x to the 0 there? Because x to the 0 is obviously 1, and 1 times 3 is 3, right? So now you can compare them and say, oh, yeah, 2 is definitely greater than 0. So via the horizontal asymptote test, a horizontal asymptote is 0. Easy. Now the vertical asymptote, I now need to go back to chapter 1 again. Because in the previous examples that we worked on, our vertical asymptote was based on the transformations of the reciprocal function, right? Well, we don't have the reciprocal function here. We don't understand what the transformations are. So we got to go back and remember, where did the vertical asymptotes come from first chapter? Those were the values that made the denominator equal to 0, right? So all we have to do is just set the denominator equal to 0. Now, we do have to be careful, because we could still have a discontinuity in the denominator, but it not be a vertical asymptote. Because if it gets simplified out, then we know it's a whole, right? Now, obviously, I know that that's not going to be the case here, because I only have a number 3 in there. But some of these other problems, you might want to double check. You might want to factor it first to make sure nothing can be simplified out, okay? Because you could have a whole instead of an asymptote. All right. Now, in this case, I can just add the x squared to the other side. You could factor this using difference of 2 squares if you wanted to. But I'll take the square root of both sides. X is going to equal plus or minus 1. Please make sure you include the plus or minus, guys. Okay? It's no longer cute to be like, oh, I just forgot the plus or minus. Because you guys are going to look. You're going to look at this graph and you're going to see this is very, very important to make sure you get both. Yes?
Oh, wait. Never mind.
You could solve this many different ways. All right, so we found our vertical asymptote, horizontal asymptote. Now, let's go ahead and find the x-intercept. Remember what I said, guys? Here we have a rational expression. Can I just set the numerator equal to 0? Right? And again, I have a false statement. So there is no x-intercept. For the y-intercept, it's probably best not to include that x to the 0 so you don't get confused. For the y-intercept, remember what I said the trick was, just take the constant over the constant. My constant here is 3. My constant here is 1, positive 1. So y equals 3 over 1, or y is equal to 3. Okay? Now, before we just say, oh, looks like everything's good,